Hi, my name is Jose Matos. Today, I'm going to speak with you about a very interesting topic that I believe it will be one of the topics for the near future. So I'm going to share with you my presentation. I'm going to speak about the contribution of artificial intelligence tools in intelligent transportation management systems. This presentation is co-authored by two of my collaborators, Joaquim Tinoco and Mário Coelho. So, the outline of my presentation, I will start with some general issues about what is artificial intelligence. Then I'm going to speak a brief about what are the transportation infrastructure management systems and what we have today in the world. And then I'm going to go a bit on the application of artificial intelligence tools on three stages of the transportation management systems. And these stages cover the performance assessment, the performance predictive models, and the decision making, which are the main stages of any transportation management system, infrastructure management system. At the end, I'm going to speak about the main conclusions and future issues about this application of artificial intelligence tools on transportation infrastructure management systems. So, what is artificial intelligence? Artificial intelligence is defined as the ability of a digital computer or a computer-controlled robot to perform tasks associated with intelligent beings. The term is a lot applied to the project of developing systems endowed with the intellectual process characteristic of humans, such as the ability to reason, to discover meaning, generalize, or learn from past experience. And what tools do we have for artificial intelligence? We can split the artificial intelligence tools in 6 main topics. The first one are tools which are ready or used for search and optimization. The second one for logic issues. The third for probabilistic methods for uncertain reasoning, too much related with probabilistic and use of artificial intelligence to get a more accurate definition and less uncertainties. The fourth on the classifiers and statistical learning methods. The fifth, which is the most used one, is artificial neural networks. And the sixth is related with evaluating progress of our lives. And these are the tools that we have in our hands. I'm not applying all of them in transportation infrastructure management systems, but I'm giving you some, later on, some applications of some of them in our in these infrastructure management systems. So now going to transportation infrastructure management systems. Typically, we do the management. We start at the component level where we assess the deterioration and the performance of our components. And when I'm speaking about components, I'm speaking about bearing devices, piers, decks, components of a bridge, but also components of a slope. We can have different stages, different places of any slope, and also components of a pavement, abdominals or whatever. We can speak about components, small elements of an asset. Then we have the asset or the system, depends on the terminology. And here we do the maintenance typically at the system level and or the asset level. And also the inventory is made at asset level. But the fact is that the decision making and the management itself is made at a network level. So there should be a high connection between the component, the asset at the network level for transportation management systems. And what we see nowadays is that most of our transportation management systems cover the component and the asset. They do not connect with the network level. So going again, I spoke about this component, asset, and network. And what are the main stages of a management system, or what should be, because most of them do not have these stages. So this is what we should include in a management system. We should include the deterioration of the component. And for that, we need to get data, and typically the management system nowadays, they get this data. Most of them, it's a condition-based management system, so they only get data, visual inspection data from the condition of the component. But more recently, some are getting in a more deep way, and they get more other kind of data from NGTs, and they mix this data with condition, with visual inspection data and so on. But this is the data about the deterioration of a component. Then we need to do the performance, or to calculate the performance, and we need to predict the performance. And not all management systems do predict the performance, or do not have models for doing performance prediction. Most of them, they only focus on the database, on the what I said before, on the deterioration level. After we predict, which is already good, those systems that already have some predictive models, but after we need to do optimization. We need to simulate different maintenance strategies, and then we need to implement an optimization algorithm to define what are the best strategy from those possible strategies that we have. So we do optimization, and at the end, we can do decision making. I want to say here that the algorithm or the software do not replace human. No one replaces human. So the decision making should be always made at the end by humans. But what we want here, and the future infrastructure management systems, they should support human on their decision making process. And typically we start from a component, then we go to the asset, and then we finalize at the network level. This is a brief resume of the management systems for transportation infrastructures that we have worldwide. You can see here the country, the name of the system. Some systems are owned by governmental entities, others by private organizations, and some few by universities. You have here the current versions from the last versions of these systems. And what I want you also to focus is the asset types that some systems cover or not, because when we want to do the management, we need to do it in an integrated way. And here only the Australia one cover all asset types. I mean, bridge, tunnels, slopes, pavements, and other assets. And also this one from Canada also covers, and the one from Finland, the RAMs also cover. But a lot of them, if you see here, they're only bridge management systems. They are not transportation infrastructure management system, because when we speak about transportation infrastructure management system, all these assets should be covered. And the other fact, which is quite interesting, is that, so that's why we spoke, most of them are bridge management systems, but other fact is that not all do it in an integrated way. When I mean in an integrated way, is that they consider the stock of bridges or the stock of assets and integrate everything together. Only a few do that in an integrated way. And this is important because it's something that we need to think on the future, because the transportation infrastructure is not only one single bridge, it's a combination of bridges, a combination of bridges with pavements, with slopes, and the owner is the same one. So a part of being different assets, different systems, the fact is that our owner is the same one, so we need to do it in an integrated way. Here you have also some others ones. In Portugal, we have, and I can say because it's the one that I was too much active, is the Sustims, which was developed for a private concessionaire in Portugal, and includes almost everything in an integrated way, except tunnels. But you can see here the status, more or less, of our management system for transportation infrastructures. The other table, that is a very and quite interesting comparison. I spoke about the three main stages of a transportation infrastructure management system, which means the first is a database where we store the condition. Could be visual inspection, could be NGT monitoring, or it could be any other kind of performance indicator, more advanced. And in this database, you can see almost all of the management systems, they have the database, it's true. Then if you go to predictive models, some have, but some do not have. And those that have, typically, they are more regressive models. They are not so stochastic or even artificial intelligent models. It's more regressive models. So it's still a topic to research and to go deep on that. And if we speak about optimization, is even less. So only a few do optimization and support the decision making. Here you have also some other management systems. In the case of systems, which is the one that was more connected, we have the 3, we developed the 3, and we are implementing already. But there are others also that have, like the Japanese and one in Switzerland, Cuba. But the fact is that still, even with the predictive models and with optimization, they are not doing that in an integrated way. So this is the fact. And this is the status nowadays of our transportation management systems. The last, and this is also quite interesting table, is a comparison considering the technological indicators. I split it here in 2 types of indicators, the one used for the management platform and other additional tools. If we see some are using the web or the cloud for doing the management system, so it's possible to do the management on the cloud. A lot also use GIS. GIS is a tool that is being applied widely in the management system. If we saw here to the big data analytics, it's good to see that this is being used. There are many management systems that already do big data analytics, and combining also artificial intelligence tools for doing this kind of analysis. Also business intelligence. But if we speak about additional tools, some use mobile platforms to do the visual inspection. But if we speak about BIM, virtual reality, augmented reality, and drones, less are being used that. So BIM, some are using, but only some. And if we speak with virtual reality, augmented reality, almost none is using. And if we speak about drones, I know that we are applying drones also, but it's not completely connected with the management system itself. So this is the status of the other management systems, as you can see here. And this is a very good comparison in terms of technological advancement of the management systems nowadays for transportation infrastructures. So at the end, what we can do is that there is already advancements in the management systems, but there is still a lot to do. Now, as I told in the outline, I'm going to split my presentation in the 3 main stages of an infrastructure transportation management system. The first one is the application of AI tools on performance assessment of such transportation infrastructures. And when we assess, we can do it with visual inspection. We can use NGTs, or even we can use monitoring. So how the AI tools can be used in order to make a more efficient assessment. And I'm going to provide you some examples from our research projects and from our developments that we have here at the University of Minho. And one of these examples is this bridge. This bridge was assessed through a reliability analysis. We made a reliability analysis. The reliability indicators, it's not often used. In some countries, they are using reliability analysis, but mostly is only condition based, and it's a component level. So the reliability is made at the asset level. So you can see here the model of the whole bridge, and it's an indicator that is not so easy to get, because you you need to calculate, you need to use numerical modeling to determine, to obtain such indicator. But it's a very important and more objective indicator than the condition when. And what we did here, we start to use Bayesian inference as an AI tool to first to reduce the statistical certainty of our parameters, and then we combine another AI tool, an evolutionary algorithm, in order to identify the most relevant parameters of this bridge, and compare this with threshold values in order to check first if this parameter, if the reliability that we are calculating at the end is or not within the threshold value. So in resume, what we did, with the data that we got from the bridge, we applied the Bayesian inference to get more accurate values from our parameters. And with such distributions, we calculate the reliability. And then we did a parameter identification process where we use the evolutionary algorithm to identify these parameters, such as the concrete strength, such as the steel yield, all these parameters that were relevant. We use AI tools, first to reduce the uncertainties, and second, to determine the most efficient parameters. And this way, we calibrate automatically our model of the bridge, the system model, and then we calculate the reliability. And this way, we could compare the reliability indicator with the thresholds provided in the codes. So this is one simple application of an assessment of a bridge. It's not so simple, but it's an application of an assessment of a bridge where the AI tools were used to reduce uncertainty first, and then to calculate the reliability indicator of that bridge. So you have here the publication where it was provided all the study. If you want to go and search a bit more about this application. A second application, which is also quite interesting, is about the use of emulation models. In this case was a surrogate models. In this case was a Gaussian process response surface technique. And this is mainly because we have very complex systems and very complex structures. And when we do the assessment of bridges or any other kind of structure, typically the models that we have are very, very heavy, very strong. And one way to use AI tools to make these models more soft, and this way to do the analysis in a more efficient way is to use surrogate models. This is being used more often, and this is the case of an application to a masonry arc bridge, a whole bridge that was assessed. We determined also the reliability indicator of such bridge, and we did a probabilistic-based assessment of this bridge. And we use first very heavy models, and then we calculate the surrogate model to give a more fast and efficient response, and in this way to determine the reliability indicator again of this bridge. Another application is with the classification system that was developed in this case for rock slopes, so in geotechnics, in embankments. And we applied artificial neural networks and supporting vector machines to somehow to support the classification and the routine inspection activities of our engineers. And we define in our research group earthwork hazard category. So as you know, rock slopes present a lot in transportation systems, railways or roads, and there was no classification here in Portugal about rock slopes, and we started with this classification, and then we did the training data. But the fact is that the data that you had, most of these slopes were very well state. So if you see, you can see an unbalanced distribution of that data. And due to that reason, we were somehow obliged to use artificial intelligence tools to simulate the two possibilities and check how we fit the final data that we have, so that we could train and we could see what is the response. For any kind of new slope that we have, we can use these tools in order to determine and do the prediction of this factor, the AHC factor. So if we split this tool in the data set, we split in two strategies, one for regression and one classification strategy. And then we use, because of the imbalance approach that we saw before, we have too many, from the data set, we have too many classifications as A. We use some approaches like the no resampling, the SMOT, or the oversampling. And then we use artificial intelligence tools, in this case, data mining, ANN, and the support vector machines to do the prediction. These are some of the results that we got. So as you can see here, the metrics that we use give us that, especially for good shape slopes, which is the ones that you have more results because of the imbalance, we have more A and B. But for this A and B, we have very good results. But even for the others, we have very good results. And the fact is that if we use what we define as the best model for predicting the classification and the assessment of our slopes, if we use an artificial neural network model in the prediction of this AHC classification factor from A, B, C, D, following a nominal classification strategy and applying an oversampling approach, the fact is that the outcome that you can see, this strategy gives us a very good distribution in terms of frequency comparing with the reality. So again, we could use the AI tools in a large amount of rock slopes, in roads or railways, and use this kind of AI tools to support us on the assessment and the classification of such slopes. Now I'm going to the second stage of a transportation infrastructure management system and how AI tools can be applied to develop and implement what we call of performance predictive models. Performance predictive models are models that, based on the data sets that we have, we can use them to predict and forecast. And here I give you an example of the application of performance predictive models with pavements. So in this case, we use and we implement a Markov type model, and we classify a matrix, a Markov matrix that give us the transition probabilities to develop the forecasting for these indicators, which are the main indicators for the pavements. And then once we get these indicators classified from 1 to 5, over time, we do a combined performance indicators that give us the condition of our pavements. So this study is, you can see here in this publication. The other one is a bridge that was also analyzed, and we developed a Markov type model of this bridge, again, which give us the forecasting and classification, in this case, for different components of the bridge. And this way it was possible to predict the evolution of the condition state of the bridge over time. And also we could do and simulate different strategies of maintenance strategies or repairing and so on this same curve or evolution curve. So this is the prediction model for the bridge, such as we have for the pavements. If you want, you can also go a bit. This is a publication in the ACI Journal of IAPSE, so you can go there and see this publication in a more deep analysis. But we did some more recent studies, and for bridges, in this case, we use a data set from NBA, and we compare the Markov type models that we developed before with other kind of models that can be used. And the fact, as you can see here, we compare the Markov models with the semi and hidden Markov, but also we compare with artificial neural network, which is an artificial intelligence model. And the fact is that the artificial neural network is the one that gives the most accuracy factors, because the ratio between the predicted and observed values is very close to 1, which means that here we have something to say. And the fact is that AI tools may be in the future or may replace the most widely used in the transportation management system, the most widely used Markov models. So this is to say that, in fact, we should think on using more and more AI tools, such as artificial neural networks, to predict the evolution of our performance of our bridges. And the good thing is that ANN works not only with less data, but also with a lot of data. So we can train and we can, it's a dynamic process. So at the end, my conclusions from this study is that the artificial intelligence tool could be and should be a very good tool to implement in the future on the performance prediction of our assets in the transportation infrastructure management systems. So here you have an example also of applying artificial intelligence tools for predicting the behavior in the with time of the pull-out forces in the use of strengthening and repairing on concrete bridge decks. And also here you can see an application of using Markov type models in order to predict the behavior of rock slopes with the time. So here is the accuracy, the performance of the model, and here is the prediction of our model. The accuracy is more than 80%, which is very good in this case, and I fully recommend. The last part of my talk is concerning the application of AI tools in the decision-making procedure. So once we have the data set, once we have the prediction, then we need to do optimization, multi-criteria optimization. In this case, it is made for pavements. We developed a Pareto curve, and we use an evolutionary algorithm, a global optimization algorithm, which is an artificial intelligence tool to get the most reasonable set of solutions. And from this solution, then we can support the owners making their final decision about what is the best maintenance strategy. So any more information you can get in this publication, as well as all all others. This is the same, but for application, but for concrete bridges with different strategies for 20 and 30 years. And we apply an artificial intelligence tool in this case for getting the best results. And this also application of an artificial intelligence tool, evolutionary algorithm, to get the best trade-off solution, in this case for rock slopes. Now we are going to the conclusions, and since we are a bit out of time, I'm going to provide you the main conclusions and future issues. And as the main conclusions, I must say that AI tools are already being used worldwide since some years in order to solve complex and computational costly problems. We can split these tools in search and optimization, logic, probabilistic methods for uncertain reason, classifiers, and statistical learning methods, ANN, and evaluating progress. Management systems are being applied worldwide in a more extensive and wide way on transportation infrastructures. And some of these systems already incorporate new technologies and tools such as artificial intelligence. And transportation infrastructure management systems are divided in three main models. So performance assessment, predictive, and decision making. And AI tools are being implemented in an efficient way, not to replace humans. This is something very important, but to make the decisions faster and reliable. In line with this, some applications to different assets were provided. Of course, you have the papers. You can go more deep on each of one, pavements, slopes, and bridges, and you can contact me if you have any doubt. And AI tools are used on search and optimization in these applications. So the evolutionary algorithm that I showed you before was used as an AI tool for search and optimization. Also, they are used for probabilistic methods for ascertaining reasoning, such as the Bayesian inference, where we can use Bayesian inference to reduce and do the ascertaining reasoning, and also on classifiers and statistical learning methods, such as the use of supportive vector matchings and ANN for do the classifications of the rock slopes, such as I said before, and also the use of ANN for doing the prediction, the performance prediction of our assets. And to finalize, as a future issues, it is verified that AI tools provide very good results, but new and more tools which gave excellent results in other fields, such as in medicine and many other fields, should also be implemented in the field of infrastructure management. So this is something that there are new AI tools that are being developed more and more efficient, and we don't need to be afraid in the construction industry to implement these kind of tools to support our decision making, our management of our infrastructures. Also, it is still missing the implementation of infrastructure management systems, not per component or asset, but for the whole network. This is something that I already mentioned before. In all kind of systems that are provided, the network analysis is something that is missing and doing that in an integrated way. This is because the transportation management should be developed at the network level. We cannot do decisions or take decisions only for one asset. And finally, a fully integrated approach, which integrates AI tools within an infrastructure transportation system in order to obtain a complete digital twin model of the whole network, is still a missing point. I think this is the future. We need to use the technology and the drones, all this stuff, virtual reality, augmented reality. We need to have digital twin models of our transportation infrastructure assets, because this will support us better and better in getting more accurate decisions. I know that our industry is a bit strong industry and difficult to enter in the technologies, but we need to push hard for that, because this will allow us and our owners and so on to make better decisions. So if you have any questions, you have here my email, my contact, and I'm completely free to answer your questions. Thank you very much, and open to questions.